Hello again, welcome back. In our last lecture, we went over 7 different Agile methodologies and really focused on 4 of them primarily. The other 3 were really just bonus content or side quests of information that might be helpful in some specific situations. But we also took a little detour down the time cost quality pyramid when we were looking at the dynamic systems development model, or DSDM. So that's all good. Keep that stored away for future use. Now, if you've had me for GIT 540, you might already know that I have some strong feelings about our roles in the graphics industry. My degrees in this field are degrees of science, and therefore I believe that design should be a science, not an art. Since design is scientific, it therefore has to be measurable. This process of measuring the effects of our work is too often overlooked, frankly. We get the brief, we execute the project, we launch it or send it to print, then suddenly we think our work is done. This is wrong. So we're going to cover that today, and we're going to talk a bit about some of the ways that we can measure the success of our projects as designers, because it is truly that important. Today we will be discussing key performance indicators, or KPIs. We'll give you a little introduction to Agile metrics. We'll talk about Agile teams and how they measure their results. Burn up and burn down charts, that one gets a little complex, so hold your breath for that one. We'll talk about in the moment Agile measurements, earned value over time Agile measurements, and that should be it, which I say it, but it's gonna be a lot, so just buckle up. There's lots of math here. I like to preface this section with I went to design school, not math school, so you have to be kind to my arithmetic here. Some of your learning objectives are define Agile project performance metrics, explain the purpose of Agile KPIs, compare burn up and burn down charts, analyze Agile project management challenges, and apply empirical metrics to Agile projects, or any project for that matter, but mostly Agile. All right, KPIs, or key performance indicators, are a means of measuring a team's performance to ensure they are on track to hit their project objectives. Almost any job you will ever have will have some form of KPI. If you're in sales, your KPI may be a certain number of sales, or a specific number of items in a customer's cart, or most commonly a specific dollar value. Sometimes it might even be all 3. If you're in management, perhaps your KPIs are a specific team attrition or turnover rate. Perhaps it's the team's output, or it's to reduce spending. Again, maybe all 3. If you're in design, maybe your KPIs are to complete projects within a certain number of days, or maintain a specific number of clients. Or if the organization you're working for is really good, maybe they're monitoring individual CSATs, or customer satisfaction scores, for each of the clients you're working with and using that as your KPI. Again, perhaps it's all 3. If you're a photographer or a videographer, perhaps they're looking out for a certain number of shots sold or a specific output of scenes per day. If you're a software engineer, perhaps it's a specific number of code lines or tasks completed per day or week or month or quarter or year, etc. All of that to say that there are countless ways that your efforts as an individual contributor on a team or by yourself can be measured. And frankly, it's not much different for individual projects either. So, what are KPIs in Agile specifically? It's the same idea. An Agile team uses specific metrics to measure performance throughout each iteration or sprint. And these indicators are used in strategic planning to guide the direction of the next iteration. As the name suggests, the world of Agile moves very quickly. One of the core principles of the Agile Manifesto is that working software should be delivered frequently within a short time frame. This fast-paced environment might suggest that Agile teams don't have time to track KPIs as they work. However, that's generally not the case, as Agile professionals are also focused on continuous improvement. Again, that's another one of those Agile methodology or principles within the Agile Manifesto. The incremental approach to producing deliverables means that they aim to improve with each iteration. And if you're not measuring, how can you improve? How do you know if you're hitting those metrics or not? Agile KPI metrics are key to helping teams up-level their performance and surpass previous efforts. There are many ways in which Agile KPI metrics can benefit a project team. You can use progress tracking, first and foremost. KPIs help teams to effectively track a project's ongoing progress. This means any potential obstacles can be spotted at an early stage and addressed before they escalate. And this ties in with the adaptable nature of Agile, whereby teams pivot quickly to make changes and improve a project's deliverable. Decision-making is another one that you can use. KPIs help leaders to make decisions about teams' workload. By using sort of KPI analytics tools, sometimes it might even just be a spreadsheet, managers can really quickly and easily see if their team has the capacity to take on more projects or user stories or features, or if they should maybe reduce the number of projects or stories or iterations or features for their next iteration. And then you can also use KPIs for insight creation. KPIs give really valuable insight into how an Agile team works. They enable you to see at a glance which areas teams lag in and which ones they sort of power through. By tracking KPIs with each iteration, you can also build up a bank of data, which will be particularly useful for employee performance reviews and for providing training in the areas the team might be lacking in. In Agile project management, the team's ability to predict completion or to use what's called traffic light statuses, red, yellow, green, to describe the project becomes a bit problematic. And in some cases, just entirely unhelpful. So let me ask you this. If I told you that at this point in the class, you're about 46% complete, what does that information do for you? I want you all to take a moment to respond. Throw it in the class Slack channel. What does that information do for you? This is a great example of what stakeholders will often do. They'll come into a meeting and say, we're 90% to completion, or we're green-lighted for project completion. In either of these situations, what would happen if a wrench got tossed into the mix? Maybe the team discovers some missing requirements or surprises or finds that the product doesn't integrate the way they thought it would. The project is only partway done, and the traffic light status reporting does not reflect the project's real state or status. Too often, the project team realizes it will need just as much time to complete the remaining 10% of a project as it did to complete that 90%. For too many projects, the team realizes they are at most 10% done because of issues or new requirements the team uncovers at the finish line. The problem with predictive measurements is that they often do not reflect reality, which is kind of a tough thing to say. It often happens that a project status light is green up until 1 month before the release date. This is sometimes referred to as a watermelon project. It's sort of green on the outside, but red on the inside. Oftentimes, project status lights turn red with seemingly no warnings because there's no empirical data about the project until just 1 month before the release date. Metrics for Agile projects contain a lot of meaningful information that provide a historical track record because Agile projects deliver value, finished work, on a much more regular basis. Project teams can use that data for improving their forecasts and their decision making. So the important thing to note here with Agile projects is that surrogate measurements like percent done are much less useful than empirical measurements like finished tasks. Agile also helps teams see problems and issues so the team can diagnose and address them. In addition to quantitative measures, the team can consider collecting qualitative measures. Some of those qualitative measures focus on practices the team has chosen and assess how well the team uses those practices. For example, the business satisfaction with delivered features or the morale of the team, and really anything else the team wants to track as a qualitative measure. So let's take a minute to do a quick little exercise. I am going to walk you guys through this exercise, and I want you to throw your response in Slack, if you feel comfortable doing so. On a scale of 1 to 5, with 1 being awful, maybe you feel like you should be in the emergency room, and then 5 being ecstatic or terrific, you're on top of the moon, all your work is done, you feel great. Tell us in Slack what your rating is. Are you a 1? Are you a 5? Are you a 3, a 4, a 2? Tell us what it is in Slack. If you'd like, you're welcome to give a little explanation. I'm going to give you all a minute to do that. Pause the video, come back once you've added that to Slack. Wonderful. Thank you all for sharing. In that exercise, I was able to collect both quantitative and qualitative data from each of you. I was able to gain a confidence metric that tells me roughly how the room is feeling on a scale of 1 to 5. Then, I was also able to gather some qualitative data on why you might be feeling that way. And in some cases, this qualitative data can actually be more helpful for project managers. For example, let's say everyone was feeling a 1 or a 2. As your professor, I want to make sure you all are learning what you feel. I want to make sure that you all feel confident about what you're learning, about the materials that you're studying. Had I only asked for quantitative data, the measurable numerical data, the 1 through 5, I may go off and make changes to the class that actually make the data worse because I didn't understand it. However, since I was able to gather quantitative data and qualitative data together, I now have a story that can inform my decision making. That way, if you're feeling like a 1 or a 2 because you have a midterm coming up in another class and it has nothing to do with my class, I don't go and make meaningless adjustments to your workload. That happens all the time in our work. Someone will step into the project and report some wild quantitative data that makes some crazy changes to our project workflow that actually impedes the work we're doing and creates worse results. So I can sum all of that up by saying agile teams need to measure results, both quantitatively and qualitatively. Agile really favors empirical measurements, which rely solely on observable data and facts gathered through direct observation and analysis. But it also values value-based measurements, which incorporates subjective judgments and importance or worth alongside objective data. Other predictive measurements that focus on identifying indicators that can forecast future outcomes based on current trends or behaviors are much less important in Agile. In other words, Agile measures what the team delivers, not what the team predicts it will deliver. Agile is based on working products of demonstrable value to customers. Again, another one of those Agile manifestos. We just keep coming back to those. So probably take some time to get used to them, memorize them, understand them. A team that is accustomed to having project baselines and estimates of earned value and return on investment, or ROI, might be a little bit puzzled about working on a project and not managing to a baseline. Agile is based on delivering working products of demonstrable value to customers. Again, one of those Agile manifestos. Go make sure you know those. Project baselines are often an artifact of attempted prediction that almost always or just typically fail. Perhaps a colleague goes out on maternity leave. Someone retires or has to take a long-term FMLA, family medical leave of absence. Perhaps your workload is more than you can handle. All of these variables and more, there are so many of them, I couldn't even name them, and they are more common than you may think, could result in a project missing its deadline. In Agile, if there is low variability in the team's work, and if the team members are not multitasking, the team's capacity can become very, very stable. This allows for project managers and product owners to provide better predictions, but typically only for the next couple of weeks, not a far out project end date type of prediction. The work we all do in the graphics industry, like other knowledge work, is about learning. Learning while delivering value. Learning really takes place by experimenting. Again, another reason why you are getting a degree of science in this program. Learning takes place by experimenting, delivering small increments of value rather than one large project completion, and getting feedback on what has been accomplished from a wide variety of people, not just professors. That's called testing. So again, here we're using the scientific method to get us through what may be seen as a more objective, or actually design is a very subjective field. We're using an objective method to get us through a very subjective topic. All right, we're gonna get a little mathy here in a little bit, but because learning is such a large part of most projects, the team really needs to balance uncertainty and providing value to customers. Once the team has delivered that value to the customer, they can plan the next small part of the project. The team reports empirical data and then replans further small increments to manage the project's uncertainty. What you're seeing here is called the cone of uncertainty, and it is just one tool that can be used to help balance the frequent delivery of customer value and the varying degrees of uncertainty the team may face in a project. By monitoring this cone of uncertainty through the project's life cycle, your team can make more informed decisions, manage uncertainties effectively, or at least more effectively, and ultimately deliver a much more successful product. Leadership often wants to know when the project is going to be done. Once the team establishes a slightly reliable velocity, such as the average number of stories or tasks that the team can complete in an iteration, the team can then predict how much longer the project is going to take. As an example, if the team averages 50 story points per iteration and the team estimates there are about another 500 points remaining, how many iterations are left? Add what you think the answer to this is in Slack. Take a moment to respond there. So the team estimates that it has about 10 iterations remaining based on this. As the project owner refines the stories remaining, and as the team refines its estimates, the project estimate could go up or down, but the team can provide an estimate. That's kind of the nice thing here. Here's another one for you. If the team averages a cycle time of 3 days per story, and there are 30 remaining stories, how many business days would you estimate until project completion? Take a moment, throw this one into Slack. The team should have about 90 business days remaining, so approximately 4 to 5 months. Okay, this is the math part. Brace yourself, it's a little hard to grasp sometimes, but if you have questions, please feel free to reach out to me in Slack. I'm happy to sort of walk through these a little bit deeper. Some iteration-based projects used what is called a burnup, or on the other hand, a burn down chart to see where the project is going over time. Really, these are both the same chart. The only difference between them is that the axes are flipped. Literally, it's the same chart, just one is upside down from the other. This is an example of a burn down chart where the team planned to deliver 37 tasks. Tasks rate the relative work, risk, and complexity of a requirement or of a task. And many Agile teams use tasks, sometimes called story points or even features. And they use those to estimate the amount of work that a project might be. So the dotted burn down line is the ideal project path that you want the project to go. Fun fact, it never happens. The project never follows the ideal path. In this chart, the team can see by day 3, they are already at risk for not delivering the project on time. And ultimately, they don't end up delivering the project on time, but they end up whittling their way back down closer to the burn down line. Some teams prefer burnup charts. Really, that's just the difference between these two, is which one does the team prefer. This is literally the exact same chart, exact same data from the burn down chart, but effectively flipped upside down. The difference is simply that some teams prefer to see their progress as whittling the work down to 0, almost treating the tasks like a checklist. In this scenario, you would use a burn down chart, like I showed previously. Whereas other teams prefer to view their work as building up towards a product launch. And in this scenario, you would use a burn up chart like this one here. So to recap, either way, both charts show the work that has been completed, and both burn up and burn down charts are based on the same data, but displayed in 2 different ways. Teams may prefer how they would like to see their data, so just check in with them to see how they like to see it, if that's something that they're familiar with. Sometimes you can just pick and they won't know the better. So consider yourself educated there. Burn downs show the effect of team members multitasking, stories that are a little bit too large, or team members that may be out of office. In my experience, when a team sees the tasks it has not yet completed in an iteration, the team generally becomes a bit dispirited or could potentially rush to complete the work without actually meeting the acceptance criteria. Meanwhile, the team could have any number of good reasons for not completing the work within the projected timeline. Whether teams use burn down or burn up charts, they will see what they have completed as the iteration progresses. At the end of the iteration, they might base their measure of capacity, how many stories or story points, on what they completed in the previous iteration. This allows the project manager, along with the team, to replan using more accurate metrics where the team is more likely to succeed in delivering the next iteration so that they can improve those going forward. Agile velocity measures how much work an Agile team can complete in a given time frame. It's calculated by dividing the amount of work completed by the time it took to complete them. So let's say we ran a 2-week sprint on a project and we were able to complete 40 tasks on our checklist. What is our daily velocity? I'll let you all throw that in the Slack channel, pause the video, come on back once you've added it. The answer here is that we could reasonably deduce that we could complete 4 tasks per day, right? This very simple calculation, so long as you're accurately tracking the amount of time it takes to your team to complete tasks, and when each task is completed, those 2 things are really important. As long as you're tracking those 2 things, they can be incredibly helpful in communicating to stakeholders a much more realistic amount of time you think it will take for a project to get completed. Now, again, most of those were somewhat predictive, and a lot of Agile projects really, the prediction methods don't matter as much. But the reason that I gave those to you is because stakeholders are going to ask for them. So you need to be able to answer those questions. While burn up and burn down charts are probably some of the most common ways to measure team performance, there's plenty of other ways to do so. However, some of them may actually stem back to keeping track of a burn up and burn down chart. So that's also why I started there. So let's talk about lead time. Lead time is the total time it takes to deliver an item measured from the time it is added to the board to the moment it is completed. Again, this has its roots in a burn chart because the more data you have on varying yet similar types of projects to what is being requested, the more capable you are at giving more accurate lead times. Taking a look at cycle time, let's say a stakeholder walks by your desk and says, hey, I need you to design me this brochure. Here's all the copy. Let me know what else you need. Cycle time is the amount of genuine working time that it takes to complete that task. Oftentimes we'll express completion in number of months or days. Cycle time aims to pinpoint down the exact number of people hours or man hours applied to that task, and would therefore require much more rigorous timekeeping. So a lot of creative agencies out-of-house roles in the graphics industry will leverage cycle time not only to track their employees' output, but also to bill clients if the agency is working on a staff hourly agreement. Again, using the same example of the stakeholder needing a brochure designed, how long will it be before you can clear your plate of your other tasks before you start working on this new one? The amount of time a project simply lies in wait, plus its cycle time, is its response time. In this example of a Kanban board, the work in progress, or the WIP limits in yellow, sort of the yellow boxes at the top of each column there, allow the team to visualize how to pull work across the board. When the team is at their WIP limits, the team cannot pull tasks from the ready column into the develop column and user test column. Instead, the team has to pull tasks from the system test column, which is also currently full, and needs to ask themselves, what do we need to do as a team to move this work into the done column? So if you're looking at this here, our system test column has 2 tasks in it, and we have a task limit of 2. So before we do anything else, we need to move something from the systems test column into done so that we can then move a develop and unit test task, which has a limit of 3, and there's 3 tasks in there, down the line, and then we can move another ready task into the develop and unit test. So before we add anything, this is where those work in progress limits become really, really critical. Pardon the horribly inaccessible font colors for just a moment. This was the only real visual way that I could think to break this information up for you. If you're struggling to read this, I apologize. I'll be sure to break it all down for you, but if you have questions, let me know in Slack. I can try to sort of make this in black and white or something. Burnups and burndowns, which are viewed as capacity measures, versus lead time and cycle time, which are seen as predictability measures. And both are useful for in-the-moment measurements. They help a team understand how much more work they have and whether the team might finish on time. For example, when teams depend on external people or groups, you can measure the project's cycle time to see how long it takes for the team to complete that work. You can also measure the project's lead time to see the factors, tasks, or stakeholders outside the team's direct control that influence the completion or progress of their work. Again, in this example, the amount of time it takes to move something from the develop and unit test column to the done column is that task cycle time. And each task is unique, so its cycle time will also be unique. However, a project manager might notice that smaller tasks have smaller cycle times. That is just the nature of the work. So if the project manager wants to see a faster throughput of tasks, they can sometimes break those tasks into smaller micro tasks, and breaking those larger tasks into those smaller pieces, or work with the team to push those tasks through a little bit quicker sometimes. And then teams can also measure the reaction or response time. And this is just a fancy way to say the amount of time that it takes to move a task from ready to the first working column, to just see how long it takes for the team on average to respond to new requests or tasks. From there, this same process can be built out into what's called a cumulative flow diagram, and that's illustrated here. This shows the work in progress across a Kanban board in effectively a chart view. For example, if a team has a lot of tasks waiting to be tested, what's going to happen to this chart? I'll let you guys throw that one in the chat too. Sorry, lots of chats in this one, but it's really important because I want to make sure that you understand what each of these charts are showing. So pause the video, throw it in Slack, let me know what you think this chart would do if a team has a lot of tasks waiting to be tested. What's going to happen here? All right, so here's what would happen. That orange testing band is going to swell. That's it. And the nice part about visualizing project work in this way is that you can see the work accumulating in each stage of the project at a very quick glance. A lot of teams have trouble with accumulating work, meaning they have work in progress rather than work completed. When teams have a lot of work in progress, the project gets delayed That's just how it works. The longer it takes for a team to deliver tasks and features, the more pressure a team will have as more tasks get added to the project. Again, major apologies for the accessibility on this chart, but the other nice thing about this chart is that you can easily overlay those response times, lead times, cycle times, remaining work, and work in queue over top to get a more accurate timeline for each of these. Now, those in-the-moment measurements are great for some things. However, measuring individual tasks and capacity is very different than measuring completed work, which is a very different concept that we call earned value, or sometimes earned value over time. While in-the-moment measurements are still necessary to have on hand, they should not be our sole project measurement. For example, if I asked you to make a peanut butter and jelly sandwich, where would you start? Perhaps get your supplies. Peanut butter, jelly, bread, a plate, a knife. On one piece of bread, we would need to use the knife to spread the peanut butter. On the other piece of bread, we would use the knife to spread the jelly. Then we can put the two pieces of bread together, set it on the plate. If you're like me, you like your sandwiches cut in half diagonally, specifically. Then you have your peanut butter and jelly sandwich. But if you had simply stopped at the first step and only given me the supplies you gathered, I think we could all agree this would be a disappointing sandwich. It certainly is not a finished product, or at least not the product the customer was asking for. Those steps we took to actually build a peanut butter and jelly sandwich were all of the tasks, whereas the end result was the earned value product. Had you just delivered to me the tools needed to make my own peanut butter and jelly sandwich, I, as your customer, would have been frustrated and it would have violated the first, but most importantly, the third principle of the Agile Manifesto, which are the primary measure of progress is working software. Or any other product if you're not creating a software, like a peanut butter and jelly sandwich, for example. When teams provide their own units of measure, they are much better able to assess, estimate, and deliver their work. The downside of relative estimations is that there's really no way to compare teams or add velocity across multiple teams. And the team can measure completed tasks in a burnup, burndown chart, or even use a variation that tracks backlog burnup, is what we would call it. And these charts are really helpful in providing trends of completion over time, as shown here. Now, task burnup and burndown charts may show that requirements grew during a project, but in this example, the red tasks complete line shows that the team hopefully completes features at a somewhat consistent pace. The dashed total features line shows how the project's total features have changed over time. For the record, it is more typical that the number of tasks will increase throughout a project's lifecycle. As teams get to work on tasks, it is relatively normal that they will uncover new ancillary tasks that need to be added to the project task list. So that's totally normal to sort of see spikes in the total features line. Then the yellow tasks remaining burn down line shows that the rate of task completion varies throughout the project lifecycle. Every time tasks are added to the project, or a staff member is out of the office, or a number of other completely viable reasons could result in a shift to the burn down line. Something that should be apparent by this point is that earned value in Agile project management is based on finished or completed tasks, features, products, as shown here. This backlog burnup chart shows completed work compared to the total amount of work expected at individual intervals, milestones, or sometimes iterations. Going back to our conversation about multitasking, it is typically best that a team can only finish one feature at a time. So to complete a large project that contains several features, the team will likely have remaining tasks that need to be completed and may not finish an entire feature until several more iterations have passed. The team can show its earned value over time with something like a backlog burnup chart shown here. Lastly, another way for a team to measure earned value would be to consider using this type of burnup chart. For example, note that the left y-axis represents the number of tasks as scope, and the right y-axis represents the project spend. Traditional earned value management, or EVM, metrics like schedule performance index, or SPI, and cost performance index, CPI, can be easily used in Agile projects. For example, if the team planned to complete 30 tasks in an iteration, but only completed 25 tasks, then the SPI is 25 divided by 30, or about 0.83. The team is working just over 83% of the planned rate. Likewise, CPI, or cost performance index, is the earned value, or the value brought by the completion of those features to date divided by the actual cost to date. Or, as shown in the earned value in Agile context chart, we have about $2.6 million in earned value over $3.4 million in actual costs. So let's plug exactly that into our formula, and that gives us a result of only 77 cents on the dollar compared to plan, which means that for every dollar the organization has spent on this project, the project is only delivering 77 cents worth of value. And of course, that assumes that our predictions are all accurate. In other words, this project is in the hole, so to speak. It is fiscally over budget and not delivering the expected value for the money that was spent. 23 cents of every single dollar is essentially being wasted or inefficiently spent. And on a similar basis, that may not mean anything to anyone. But when you're working on or managing projects worth $3.4 million, that 23 cents has now ballooned to almost $800,000, which could, in theory, pay a very comfortable salary for at least 8 people just in wasteful spending alone. Think about that. In early 2025, there was a lot of news around the federal government going through and slashing jobs and cutting funding all over the place. Whether you're on either side of the political item, you kind of have to look at this and say, all right, where is the waste, right? Because if there is waste somewhere and there's just $800,000 going out into the wind, that is money that could be optimized. Now, I'm not saying that any politicians are doing that exceptionally well, but it's something to think about. In this example, this team has some really big steps to take before they can get this project in the black. Every semester, I have students that come up to me and say they want to start a business or freelance, whatever it might be. And my advice to them is generally, they probably shouldn't. This right here is exactly why. Especially for most of you who are primarily undergraduates, and even some of you who are graduate students. Most of you have not had the opportunity to see the ramifications of your mistakes yet. Every single one of you will go out into the design sector and you will make mistakes. 9 times out of 10, those mistakes are not cheap. In fact, One of the mistakes I made as a junior designer was that I was designing a packaging product with a QR code that was designed to send customers to the product's website when you scan the QR code so that customers could easily reorder that product. But we forgot to update the QR code before we sent it to print. That stupid little QR code that should have only cost the company $500 for the annual tracking subscription ended up costing hundreds of thousands of dollars to reprint the packaging. My mistake. You can't imagine how I felt walking into that room and said, oops. It's a little embarrassing. But before you all get into freelancing, you first need to go make those kinds of mistakes and learn how to solve them on someone else's dollar. Because a mistake like that, if you were freelancing, could send you and your freelancing business into bankruptcy. All right. I know that was a long one for us today, and it was filled with lots of data and charts. I apologize, but I have good news. That is the end of our lectures for Module 3. When we come back for the Module 4 lectures, we're going to be talking a bit about some of the other vital functions and roles project managers play in a creative team that helps projects get over the finish line. See you there for Module 4.